right, this is Algebra 2, Lesson 27, Rational Expressions. What does the word rational expressions mean? What's a rational expression? What does the word rational mean? Okay, the word rational means that we can write it as a ratio. Yes. That something is written as a ratio of something over something, okay? And what's an expression? An expression has no equal sign as opposed to an equation. All right? So in this lesson, we are going to add rational expressions. So we're going to add them by first making a common denominator. Because the rule is if I have no equal sign, I'm going to a common denominator. I go to a common denominator by multiplying any term by what is the equivalent of 1. Then once I go to a common denominator, I'm going to write the numerators over the one common denominator. All right, so when you see these in your homework, you're adding them, and then you're going to write all of your numerators over the one common denominator. But we have to decide what the denominator is going to be. And that is what is different about this lesson. So in example 1, we begin with 4 over x plus 6 over x plus a. The common denominator is going to be those two terms multiplied. So I want my common denominator to be x times x plus a. X times x plus a. I'm moving the table. That's all right. So then I have to ask myself. Notice it just can't be x times a. Because this is one term. And this is one term. So we have to multiply them. So what do I have to multiply x by for the denominator to be x times x plus a? So I have to multiply by x plus a over x plus a. So the 4 has to be distributed to both of the terms in the numerator. So that we end up with 4x plus 4a for the first term. And for the second term, what do I multiply x plus a by to get this as the common denominator? X over x. So that I end up with 6x over that. Now is when the sign moves to the numerator and I write it all over the one common denominator. So it's 4x plus 4a plus 6x all over x times x plus a. And then I ask myself, can I simplify the numerator? Are there any like terms? And there are. So we combine our like terms 4x and 6x. And we end up with 10x plus 4a all over x times x plus a. Is there anything I can simplify in that final term? Anything that can be simplified? Okay, is that simplifying? Simplifying is Okay, but then can I simplify it? Can I reduce it at all? There's no terms that I can simplify. I could factor a 2 out, but I can't cancel a 2 in the denominator. So this would be your final answer. There's nothing that can be factored out and canceled. Does that make sense? Because eventually we will do that. Once we go to a common denominator, there might be terms that we can factor out and cancel. All right, let's look at example 2. So the problems just get a little harder, but they make more sense for what's to come. All right, I'm going to switch markers. Did I switch markers? Without paying attention. All right, look at example 2 on page 126. We now have 3 terms. We have x plus 2 over x plus 4 plus 6, no denominator, plus 2 over x squared. So what will be my common denominator for these 3 terms?
X squared distributed to x plus 4.
X squared times what?
X plus 4 in parentheses.
Times x plus 4 in parentheses. That is going to be my common denominator. So go ahead and write it. Write that common denominator. And then ask yourself, what do I have to multiply each term by to arrive at this in the denominator? So what do I have to multiply x plus 4 by to get this in the denominator?
X squared.
X squared over x squared. And I can distribute the x squared to both of the terms. And what's x squared times x? X cubed. And x squared times 2 is 2x squared. What do I have to multiply the next term by? The entire denominator, right? I have to multiply by x squared times x plus 4. X squared times x plus 4. So I'm going to distribute here first, and then I'm going to distribute inside the parentheses. So it's 6x squared times x plus 4. What do I have to multiply the last term by? X plus 4 over x plus 4. I'm going to distribute the 2 to both of those terms. And we have 2x plus 8. Because these are all positives, if they were negatives, we would have to, and I'll show you a negative in just a minute. But because they're positive, it's not going to change any of the signs. So I'm going to move everything to the numerator. We have x cubed plus 2x squared. And I'm going to distribute this 6x to the terms inside the parentheses. And they're all going to still be positive. So we have 6x cubed plus 24x squared. And then the last 2 terms all over x squared times x plus 4.
And you can simplify that.
I definitely want to, yes?
confused how you got the common denominator.
All right, so back at the beginning, we have x plus 4 and we have x squared. What were you thinking the common denominator would be?
I'm just confused how that's multiplied. You know, like, I don't know how we've been adding it.
Before, we've not had a binomial in the denominator. So you have to see this as one term. So it's one term times the other term. Before, we had denominators like 4x squared y, x, y, 8x. They were all multiplied. So because they were all multiplied, we could say, okay, well the 4, the 8, everything goes into the 8. And then we would pick the x squared, the biggest one. And then we pick the y, x squared. But here we have to see the binomial as one term. So it's one term times the other term. All right, so now let's combine our x squareds. That's x cubed, 7x cubed. Our x squareds, we have 26, right? Plus 26x squared. And then plus 2x plus 8. All over x squared times x plus 4. And you can leave it like that. Does that make sense? All right, the last one, the last example, we have to look at and factor. So y'all learned factoring. And so now it's more like multiplying, like what we just talked about. But one is a second degree term, a trinomial. And the other one is actually two terms. All right, so we have x plus 2. We have x plus 2 over x squared plus 4x plus 3 minus 1 over x times x plus 1. All right, so you need to see this, x times x plus 1, as two terms being multiplied. It's called a factor, but it's two terms being multiplied. I want to factor this first denominator. So remember, when we're factoring, we ask, what are factors of positive 3, the c value, such that we add them, the result is 4. So what are factors of 3 such that we add them, the result is 4? What are they? Positive 3 and positive 1. All right, do you see a common factor in each denominator? Yes, x plus 1 is in both of them. So definitely x plus 1 is going to be in the denominator, along with every other term. So we have an x, and we have an x plus 3. Does that make sense? You have to look at all of the terms multiplied. That was no different than looking at 4 times x times y. Just now the terms are not single variables. Now the terms are binomials. And then you ask yourself, for this first denominator, what do I need to multiply this denominator by to get this common denominator? X over X. Does that make sense? Do y'all understand the binomials multiply are just like 4 times X times Y, 4 times X times Y. They're just in binomial form now. And so when I distribute the X, I have X squared plus 2X in that numerator. And then I look at this denominator, X times X plus 1. What do I need to multiply this term by to get to this denominator?
X plus 3.
X plus 3 over X plus 3. And I distribute the 1, which just means it's X plus 3. All right, here's where mistakes are made. It's this numerator minus this entire numerator. So when I subtract, it's minus X minus 3. That negative has to be distributed to this entire term. When you write it, you could write it X squared plus 2X minus that term. That is what it means. All over your common denominator. I feel like I'm writing so crooked. And then distribute that negative. So it's X squared plus 2X minus X minus 3 all over X times X plus 1 times X plus 3. And then combine your like terms, which are here, your like terms. So it's X squared plus X minus 3 all over X times X plus 1 times X plus 3. That numerator is not factorable. There are not factors of negative 3 such that we add them and the result is positive 1. Final answer. Got it?